America. Companies are very concerned about that right now.
Mm.
But if you want to see what's going to happen in 5 or 10 years, places like island states, like Singapore, I suspect they could go all electric. Eliminate all internal combustion engines altogether. Because, not many people need to go on long journeys, make the city much cleaner. So I think you're going to see what's going to happen before we get talking new batteries is all the delivery trucks in most major cities that don't travel very far, all the buses, those are things that are going to happen. They're all going to go electric in the next 5 to 10 years. And some places, say like Singapore, maybe Santiago, Chile, maybe San Francisco, California, Paris, will ban internal combustion engines in the center of their city. I think that's the biggest change. And I think lithium-ion batteries, they're about $100 a kilowatt hour now if you're a large auto company, if you're buying them. They may drop to say $80 on a pack basis in the next 5 years. But the issue is the bigger the demand, the more the raw materials price goes up. There's not enough at the moment.
Very interesting. Thank you.
So I'm just wondering, because in this context, we're talking about lithium-ion batteries for all kinds of energy storage applications. I'm just wondering, does it really make sense to think of one technology for all these various kinds of applications? And you were talking about how we need the other technologies to create some competition, and then maybe if there's a breakthrough there, maybe it could be good for technology development. But I'm just wondering, even considering sometimes the complexity of batteries and the amount of elements that go into it, that sometimes right now, maybe we can think about grid storage, but maybe on the long term it's not. Does it make sense? That's my question for you.
So point out that energy storage in batteries for the grid is tiny compared with pump hydro.
Yeah.
So pump hydro stores 90-95% grid storage, and I think it's going to stay that way. And if you got a mountainous country like Switzerland, you probably put more pump hydro in. But then low flat countries, that's much more difficult. So the pump hydro is clearly going to always dominate. So I think if you look at the grid, the big issue for total renewable energy, you use much more energy in the summer and the winter than you do in the fall and the spring. So you have to shift the load from the spring to the summer and from the fall, autumn to the winter. You can't do that. And maybe some other storage things to come up with it. There's not many things that are cheaper than water.
Following your question, I want to ask, what's your opinion of the lithium batteries for the long duration energy storage? What's the perspective of such technologies? For example, if we can achieve more than 10% of the future market for the grid energy storage compared to the pump hydro or other compressed air, something very cheap. So what's your opinion about this? Thank you.
Redox storage, is that it?
Yes, redox flow batteries.
We worked on
aqueous based.
Yes. So we worked on zinc bromine electron the same time we worked on lithium-ion. And a lot of people working on vanadium redox. All tend to be somewhat corrosive and got moving parts. If it's a huge grid storage, I think it will work out well to get the cost down. But most utilities, certainly around here, talking say under 50 megawatt hours, they want it all in containers so they can move it around and take it from substation to substation as is needed and where they can make a lot of money. There was a vanadium redox battery built, I think in the state of Utah in the United States maybe 10 years ago. They used it for about 10 years, then they didn't need it anymore, so it just sat there rusting. So redox flow is really somewhat like a chemical plant. It's much less flexible. So you've got to make sure that you want it, and you want it for 20 years, and the utilities can actually pay for it for 20 years. And most of them are somewhat toxic. So zinc bromine, we have a complex to bromine, so if we had to spill it, it wouldn't be dangerous. Vanadium, in this highest oxidation state, is quite toxic. Once it's producing, so you spill it, you've got a toxic waste site. So you have to be very, very careful on some of these redox systems. But there's clearly an opportunity there because you have the opportunity of separate it and the amount of energy storage and the amount of power. Like things from the size of the tanks and like the chemical part of it, which you don't with lithium-ion. Yes.
I would like to ask your opinion on lithium-ion battery recycling. Metal in lithium-ion battery, like valuable metal like cobalt and nickel, is limited and relatively high cost. So metal recycling is very important topic for development of lithium-ion battery, I believe. And there are many types of lithium-ion batteries, and the recycling systems might be constructed according to the type of lithium-ion batteries. So I would like to ask your opinion on the overview of lithium-ion battery recycling issue.
So lithium battery recycling has to occur, otherwise we don't have a sustainable environment. The only way it's probably going to occur is by government policy in most places. So it has to be dictated. I don't know what it is in most countries, but if you want a lead-acid battery-free car, in the United States we don't take an old one back and trade it in. You have to pay $25 to $50 extra. So I think that's going to happen. Right now, about 100 miles north of me is the largest lithium recycling in the United States. That's run by Lithium Cycles, a Canadian company. They're in Rochester, New York. And they're recycling all kinds of lithium batteries, so lithium-ion, phosphate, cobalt, so on. They do it by a relatively clean technique, no burning. And from the black material that get out of it, they then separate it, the cobalt, the nickel, the iron. What's quite valuable in there is the copper currently. They're separating all those. They're a private company, and they say they're going to make money. I'm sure they're getting quite a bit of lithium-ion phosphate coming in as well. So the only valuable part is maybe the lithium and the copper. But there are several other companies throughout the US also doing lithium recycling. In Europe, some materials manufacturers, such as in Belgium, set up their own recycling. Apple claims they're doing the recycling. And I think the law in Germany is the car companies have to take the cars back at the end of life. They're responsible for the recycling. So it's a very active business right now. It's got to be there to recover materials. Cobalt's worth a lot of money, so the recycling companies can certainly make money. Just getting iPhone, computer, and so on back.
Yes. So actually I'm not working on this area, but like from our conversation I am
listening to. So, like you said, for the redox flow batteries, the main concern is the toxicity of the zinc and other metals, right? So,
Well, it's not the zinc, it's the bromine.
bromine. Okay, yeah. So if we consider like organic flow batteries, like organic redox flow batteries, so we can remove the toxicity part. So will they be efficient for this battery applications?
Yeah, there's quite a lot of research going on organic batteries, the one sort or another. They're very low energy density, but they should be low cost. There's interest in there. Clearly, the system where there's a lot of interest is lithium sulfur, or it could be sodium sulfur. Very large interest. Horrendous and technical issues. Sulfur and the sulfide are outstanding electronic indicators and also electric power issues. That's an area where it should be much more fundamental work with sulfur to overcome the challenge.
Okay, can I ask, like, everyone is asking about like battery and future and application and all this stuff. So like I want to ask, like, for